In this lesson, we'll talk about the integral root theorem. The integral root theorem is closely related to the rational root theorem, but this is a special case of that in that the leading coefficient is a 1. So if the leading coefficient is a 1, then you do not have to worry about using P over Q as we did in the rational root theorem. Now all you have to worry about are the factors of P. So let's look at this polynomial. And let's find the possible roots of this polynomial using the integral root theorem. So the integral root theorem says leading coefficient of 1. In this case, the x cubed has a 1. We no longer have to use our p over q. Now we can use just the factors of p. So what are the factors of p? Plus or minus 1, plus or minus 5. So we take those numbers and we can plug them in using synthetic division, or we can use the remainder theorem and then to determine if it is a factor or not. I happen to know in this case that -5 is a factor, the other three are not. So I'm going to go ahead and use -5 as a test case, and we'll use the remainder theorem for it. So -5 cubed plus 8 times -5 plus 16 times -5 plus 5 equals 0. So we simplify. We're looking for a 0 equals 0. Once we finish simplifying, that will tell us that we have a factor. -5 cubes, -125. 8 times -5, that's a square, by the way. 8 times -5 squared is plus 200. Went blank there for a second. 16 times -5 is -80 plus 5 equals 0. So when you add those together, 200 plus 5 is 205. -125, -80 is -125. No, 205, excuse me. -205 plus 205. And then we know that's equal to 0. So the whole thing is equal to 0. So that means one of the factors of this is x plus 5 written in binomial form, but the number x equals -5. -5 would be the actual root itself. So now, how do we find the other roots? We use synthetic division because we need that depressed polynomial, or the quotient, to be able to find the answer. So we use -5 in a synthetic division. So bring down your 1, that's -5. We know it's going to be a 0 at the end. It's +3, that would be a -15, so that would be a 1, and -5, and 0. So what we're looking for is that 131, that's our depressed polynomial. So that would be x squared plus 3x plus 1. Now, we want to factor this if possible. If we can't factor it, which it doesn't look like we can, then we're going to have to use not synthetic division, but quadratic formula. And using the quadratic formula, we can already tell, since those other numbers that we picked, the roots, only one of the 4 came up, so that means we have an imaginary root. And so that's where the quadratic comes in. So we would have to take our x squared plus 3x plus 1, and we would have to use the quadratic formula to determine those other 2 roots based on that quadratic. So that's the method you would use to find the other 2 roots of this polynomial.